Hi there, welcome to Machine Bytes, your go-to place to learn AI the smart way. In last video, we learned about binary class classifiers, where our aim is to distinguish between two classes. In this video, we are going to cover multi-class classifier. In this category, we can distinguish between more than two classes as well. If you have various images of cats and dogs, this will require a binary classifier where we need to identify whether in a picture it's a cat or dog. The other example could be if we have images of multiple animals like cats, we have dogs, we have sheep, lion, and others. In this case, now because we have more than two classes, we will use multi-class classifier. In last video, we took example of MNIST dataset where we are given images of handwritten digits. In this case, we could have 10 kinds of different images where digits could be 1, 2, 3 till 9. In last video, we did a binary classification here and tried to figure out if a particular image is 5 or not 5. But now in multi-class classification, we will try to identify digit in each image. So earlier, if your image was something like this, our binary classifier was saying true because this looks like a 5. But in case of multi-class classifier, the result will be 5. So it will tell us what exactly is there in this particular image. Classification algorithms like SGD, random forest, naive Bayes, these are able to do multi-class classification by default. But we also have some algorithms which are not able to do multi-class classification in their default format. These algorithms are logistic regression and support vector classifier. These are strictly binary classifiers. If we want to do multi-class classification using strictly binary classifiers, there are two methods. One of the method is to use n classifiers for n classes. That is, if we have MNIST dataset where there are 10 classes, we need to define 10 binary classifiers. So if you want to classify an image, you get decision score from each classifier for that image and select the class whose classifier output has the highest score. This approach is called one versus rest, or sometimes it's called one versus all. The other approach is to have a binary classifier for each pair of classes. So for MNIST dataset, to identify a digit 0, we need to have a binary classifier for this with digit 1, digit 2, digit 3, 4, 5, 6, 7, 8, and 9. Similarly, for 1, we will need to have binary classifier with 2, 3, 4, 5, 6, 7, 8, and 9 because 0 is already covered here. Similarly, for 2, we need to have a binary classifier with 3, 4, 5, 6, 7, 8, and 9, and so on. So if we want to have a total count of classifiers that is required here, it will be n minus 1 divided by 2, where n is number of classes. Now for MNIST dataset, this count will be 10 multiplied by 9 divided by 2, which is 45. So if we want to create a model for MNIST dataset using binary classifiers, we will need to train 45 binary classifiers for that. This approach is called 1 versus 1. Now, you might think that there will be no cases where we will pick 1 versus 1 over 1 versus rest because the number of classifiers here are huge. But that is not the case. When we use 1 versus 1 approach, in that case, each classifier is only trained over the data for classes it will distinguish. Now, if we go back, for this classifier, we will only pass images of 0 and 1 as training data, whereas for this one, we will have images of 1 and 2. For this one, we will have images of 2 and 3, like that. So in this case, the amount of training data is comparatively very less, and it makes training process faster. One of the algorithm which scales poorly with size of training is SVM. So generally, in case of SVM, we will use 1 versus 1 approach only. Here, 1 versus 1 is preferred as it is faster to train many classifiers on small training sets than to train few on large training set. For binary classification algorithms, 1 versus rest is preferred. So whenever we try to do multi-class classification using binary classification algorithms, scikit-learn by default detects that a binary algorithm is being used for multi-class tasks and automatically runs either 1 versus rest or 1 versus 1 depending on the algorithm. So in last video, we tried to predict whether a particular image is 5 or not 5. That was a case of binary classification. Now let's do practical part of multi-class classification where we will try to predict which digit is there in that image. Let's once go through the code that we did for binary classification in last video. We used MNIST dataset where we have data and target columns defined. The shape of X is 70,000 into 784. So there are 784 pixels, which we later divided into 28 into 28 to convert that into a 2D space. Then shape of Y is 70,000 and there is only one column. To visualize this, we picked one digit from the X, which is X0. And if we look at this, this is like, these are the 784 pixels for X0. If we convert them into a 2D space using reshaping for 28 into 28, we can also see how it looks like. So this is the image. It more looks like a 5. Now, if we check what is the value at Y0, it's a 5. But it's a string here, and we need to convert it into a integer value. So let's do that. We have splitted the data into train and test datasets. And now for binary classification, we want to classify whether a particular image is having a number 5 or not. So for that, we need to have our target variable as true whenever the value is 5, otherwise false. So we have updated our yTrain and yTest with respect to its value, whether it's a 5 or not 5. Now, if we see yTrain, it is saying true, false. So wherever the image is true, for example, this is X0, which is 5, hence true, and the rest are false and true accordingly. Then we used SGD classifier to do binary classification. We fit the training data set and then predict over the testing data set. So we can see for X test 2, it's saying false. It means at X test 2, the image is not of 5. And if we check what is the value at Y test 5, here also it is false. And if we try to plot the image, it is the image of 1 at X test 2. Hence the result is correct, which is saying false, that the image is not of 5. Now let's move to what we discussed today, multi-class classification. So I imported support vector classifier for that and did the training on X train and Y train. We can see here that this predict is predicting value 5, and we know that in some digit we had this 5 earlier. So it's a correct prediction. And if we want to see the prediction for each class, we can use the method decision function. If I run this, we can see for class 0, this is the output 1, 2, 3, 4, and 5. For class 5, the output is highest. That is why it predicted this image as class 5. We can do other predictions also. If I predict X test 2, it's saying it's a 1. And we have seen here X test 2 is a 1. This variable here captures all the predicted values for testing dataset. And this is just the value at Y test 2, which we earlier predicted as 1 only. Now, once we have chosen a classifier, we want to see how accurately it is able to make the predictions. For that, we are using accuracy score. And accuracy score will be calculated on the basis of the predicted values, these values, and the actual values which were there in the testing dataset. When we compare this, we found out that 97% of times our classifier was able to distinguish between the classes correctly. The other 3%, almost 2%, the decision or prediction that was made by the classifier was not correct. There are other methods also to measure the performance of a particular classifier. We will explore that in future videos. That's all for this video. I will see you in the next one. Till then, thanks and bye-bye.